I'm Judi Sandrock from MaxIQ Space, and in this short video, I'm going to take you through the MK10 Getting Started guide. That's for the Advanced Remote Sensing Kit from MaxIQ Space, and sometimes we refer to it as the CubeSat Kit. So what does it show us on the website on maxiq.space? Here we can see some photographs of the kit when it's put together, sometimes when it's integrated into a payload, and some of the description. And then you can see as well that what it is it's actually two kits in one. So what we have here is we have the remote or flight station with all of these components, and then we have the ground station. And we have this asterisk here for this note that the ground station can be configured as a TinyGS Ground Station for everybody who purchases that kit. And that's going to become quite apparent later. So our final goal really is that we want to use this kit so that we can develop our payload that eventually we can have our CubeSat in orbit communicating with our ground station. And this is where this kit is taking us, using the LoRa radio so that we can communicate between our flight station or remote sensing station and our ground station. So we have 3 steps to get there. The first is we need to build our STEM weather station so that what we can do is we can get used to using the sensors. How do we connect to Wi-Fi, to MQTT server, and then actually start the introduction to remote sensing. We look at building the TinyGS Ground Station so that we can start actually using our ground station to collect data from satellites that are in orbit. And then what we do is we configure our flight stations and our ground stations independently. And it's really important that we go through these 3 steps because they get more difficult as they go along. What we do is we start with the STEM weather station kit, and that is actually all that code has been pre-developed. And then we end up going through a lot of troubleshooting as we go through the different steps so that by the time you get to build your payload, you're fully au fait with the ecosystem and you're able to stand on your own to do that. So step number 1 is to build the weather station. And this core is pre-flashed with Arduino code so that it'll work out of the box. It displays the sensor data on the small OLED screen, and also we can connect it to Wi-Fi and the MQTT server so that we can see the data on the Kibana dashboard. So here we can see the data being displayed on the little OLED screen. Here is a screenshot of the global map, and it actually shows how many, the size of the circle shows how many of these weather stations are kits are connected around the world at any one time. And then what we have here is we have a screenshot of a very typical dashboard. It's actually for one that I'm using to monitor our freezer here in the house. So step number 2 is to build a TinyGS ground station. And here you will need to actually build your own antenna. There is an antenna connector included in your kit. And what we can see here is that there's many ground stations around the world. Unfortunately, there's large areas of the world as well where there are no ground stations. And what I did is, for the sake of this example, I actually zoomed in to Singapore, the area around Singapore, and we can see that in the region there are a few ground stations, but it's certainly not as populated as other areas of the world. The importance of putting together the TinyGS ground station is we start using the LoRa radio and we can connect to satellites and downlink their data. On this screenshot, on the map, you can also see a number of the satellites that are in orbit that are where their data is being downloaded using the TinyGS ground station network. What it is that we also get to contribute our data to the global community using the Wi-Fi and MQTT connections. And we end up understanding LoRa communication. What's going to happen is that once you launch your CubeSat, you're going to be downloading your data to this same global network. So it's a great idea to actually become a member of that network and start contributing before you need to take advantage of the value that that network brings. Then step number 3 is to build your flight station and your ground station independently. And now we're starting to get to more around satellite payloads and satellite operations. And what you can do is you can initially collect the data using the SD card interface, which I'll show you in a few minutes. You can communicate the data using your LoRa from your flight station to your ground station. And what's really important is that we haven't pre-developed any code for this stage. Yet there is a MaxIQ Space community to support you. And this is where you really get into the thick of it. And this is where the fun starts and the troubleshooting begins. So let's actually get started. Step number 1, please don't tear open the bags. The bags have not been sealed. They are Ziploc bags, so they're fully reusable. And you can see here's a photograph of a collection of some of the components for the remote flight sensor, a flight station, and here also for the ground station. And what I'm doing is that I'm pointing out here that you have this TinyGS blank. If you turn it around and follow the QR code, it takes you to all of those materials. Another thing to understand about any circuit that we're going to build is that we need 4 elements: input, output, processor, and power. And it all works with these 10-pin connectors. And also we've included some prototype boards so you can actually build your own components. For step number 1, you're going to put together your weather station. The link to the Getting Started guide is actually in the video description. But just some important notes here to have a look at is you can see that on the connector, these 10-pin connectors, there's 5 slots. And between 3 and 2, there's a little tab here, and that actually connects into the little slot on the boards. When you've connected them correctly, if you can see these 2 icons in the bottom right-hand corner, then it's correct. If you can't see the icon in the bottom right-hand corner, then it's incorrect. That's just a little bit of a practical tip before you get started with building your weather station. And here you can see what I've done is that I've actually built this weather station and I've included the MaxIQ blank chip. That is really just an additional consideration that if you'd like your kit to be more robust, then add that branded chip. This chip has no sensor on it. However, it does connect power and data communication, and placing it in the circuit allows for additional mechanical strength and connection redundancy. This is really important when you start designing your satellite payload, is you have to make sure that you can survive the vibrations of the launch, the satellite launch. And so what you want to do is you want to make sure that you've got communication and power redundancy. Way too many student satellites fail in orbit or never even turn on in orbit because the power connection, there was no redundancy and there was some solder line or cable that disconnected. And so therefore nothing works. So what you can do is with this step number 1 weather station, you can measure the environment using the OLED screen. There's some tips here also in the Getting Started guide. And then what you can do is you can go through these various steps to actually connect it to the internet. You'll see using the unit name as well as the password, and using a smartphone, you eventually actually connect it to the internet, so that what you can do is you can actually start displaying your data on the Kibana dashboard, and the links to those guides are also in the description. So steps number 2 and 3. Step number 2, we have a full TinyGS Ground Station course on Canvas. Please pop us an email, and what we'll do is we'll be able to enroll you in that course. And with step number 3, there are a number of resources. We've got a YouTube channel at MaxIQ Space. We have a GitHub site, which is domino4.com. And then also join the Discord community. If you pop us an email, what we'll do is we'll also send you a link to that Discord community, so that what you can do is you can actually collaborate with everybody else. Just some notes over here around using the extended core. This extended core is really nice because it has a number of features on it. You can see here there's a camera connector, so you can connect one of those small Raspberry cameras to it. Here is the SD card port as well, so that you can actually collect your data and write the data to your SD card. And then there's this 20-pin connector, which is used for the radio as well as some of the prototype boards. What we want you to note here is this is how you connect this rechargeable battery unit, and then also have a look at the orientation of the sensors. In order for the sensors to be able to connect to that board, this is just how they need to be oriented. What we have over here is, we can see here this 20-pin connector, and this is how the radio connects there. And then you'll also see that some of the prototype boards also use this 20-pin connector. So when you build your own components, you'll use that 20-pin connector for those particular components. Lastly, you'll see that you have two different types of antenna connector. This one here at the top, this is for the ground station, so that what you can do is you can actually connect your antenna. You can either buy an antenna for the ground station, or otherwise you can actually make your own. And in the Canvas course, it takes you through how to build your own antenna. And then for the flight or remote sensing antenna, what we've done is we've actually included a full antenna here. And you may want to upgrade this depending on what kind of distance you want to cover with your LoRa radios. And so that is it. Thank you very much. Just a quick video to take you through the MK10 kit. And please remember, the links are all in the description. That's cheers for now.